Welcome to the USGS Landslide Hazards Seminar. I'm Stephen Slaughter, and this meeting is hosted by the Landslide Hazards Program. The seminar is a twice monthly presentation by researchers, academics, students, and professional geologists from industry and government agencies who are working on some aspect of landslides and landslide science. The seminar is co-organized by Matt Thomas, Jamie Kostelnick, and me. Today is another installment of our mini series where we hear from state surveys, or in this case, somebody recently retired from a state survey. If you'd like to have your state landslide work spotlighted as part of this mini series, please contact one of our co-organizers. Today, we are joined by Rick Wooten, who recently retired from the North Carolina Geological Survey in 2021 after 31 years as a senior geologist for geohazards and geology. His work with the North Carolina Geological Survey, or NCGS, involved the scientific review and field investigation for a low-level radioactive waste disposal project and bedrock geologic mapping in the Piedmont and Blue Ridge Mountains. Since 2003, his primary focus has been on landslide hazard mapping and research, including responding to landslide events in the North Carolina Blue Ridge. His previous work experience included geologic mapping for land use planning and applied geotechnical geology with the USDA Forest Service on the Gifford-Pinchot National Forest in Washington State from 1980 to 1990. Rick, welcome, and the virtual stage is yours.
All right. Thank you, Stephen. And thank you, Jamie and Matt, for putting together this really excellent program on landslide hazards. And it's really a privilege to be able to speak here and talk a little bit about the North Carolina experience. And also, I'd like to thank everybody that's joined in for taking time out of your day. The title of my talk is the Building and Upkeep of a Landslide Hazard Mapping Program, the confluence or collision in some cases of science, history, politics, and public opinion. And it's a Blue Ridge perspective on a national challenge that we're all facing. But one thing I'd like to acknowledge is the support that the AEG Foundation and the Environmental Engineering Geology Division have given for the Johns Lectureship Program. So without that support, this would not have been possible. So my talk today is going to be sort of interwoven programmatic aspects of a landslide program told through a series of landslides. So it'll be a little bit of a mix. But for those who have not been to the Blue Ridge, you can see the picture here that at certain times in certain light, the mountains really are blue. And they are quite a picture of serenity, but often those are interrupted by periods of meteorological events and storm events that really change that to periods of a lot of landslides, landslide fatalities, damaged homes, and chaos that ensues from that. The first thing I really feel it's important to do is in this talk is to acknowledge all the people who have made it possible, because their efforts and their work cover the lion's share of the things that I'm going to be talking about today. And that's the North Carolina landslide mapping team from 2005 and 2011. And the newly constituted landslide mapping team began in 2019. But also it's critical to point out the Blue Ridge Bedrock crew. These are all folks that are here in the Asheville office of the North Carolina Geological Survey, who in those periods when we did not have a landslide mapping team, they really played a key role in responding to landslides. And in that light, I do need to point out, since I am retired from the North Carolina Geological Survey, I'll be talking a lot about the work that the survey did, but I'm not speaking on behalf of the North Carolina Survey. So what I'm saying today is really my own words. So again, I'm not speaking in behalf of any of the agencies in North Carolina Geological Survey, which is part of the North Carolina Department of Environmental Quality and within the Division of Energy, Minerals, and Land Resources. So all of my talks really evolve around interconnecting geoscience, weather and climate, and history of landslide hazard studies, and then using some of the new tools that we have, particularly lidar and drones in emergency landslide responses and hazard mapping, and focusing on the importance of building these multidisciplinary partnerships in applied geology and research, and then communicating with stakeholders about landslide hazards. So these themes really go through all the talks that I've been giving through the Johns Lecture Circuit. And I'm sure you're all familiar with the landslide hazard situation and problem we have here in the United States and worldwide. Any place there are mountains and meteorological events and earthquakes that trigger those landslides. And the most, the devastating factor about landslide problems are the fatalities that are associated with these events. And so wherever you see the white cross in the image, whether it's the Oso landslide in Washington, Montecito, California, uh, North Virginia, Nelson County, and Tryon, North Carolina, these involve landslide fatalities. And what you see in the center image here is a map that the USGS is putting together or working on as a US landslide inventory. And so North Carolina is well represented here, as well as Kentucky and the Southern Appalachians. I know there's a lot of landslides that Ann Witt has documented in the Blue Ridge Mountains of Virginia. And of course, the Pacific Northwest and California are well represented. I think the one thing that strikes me about this map is the number of blank spaces. So again, that points out there's a lot of work yet to be done and making progress towards landslide loss reduction. Very briefly, a little bit about Western North Carolina. We do have elevation here, not as much as the Western United States, but we do have the highest point east of the Mississippi. That's Mount Mitchell, a little over 6,000 feet. And we have plenty of topographic relief, which is a big driver for landslides. And this is Hickory Nut Gorge in Rutherford County. And this is actually the site of the field trip we're helping co-lead for the progressive failure of brittle rocks, the Penrose Conference in June of this year. And geologically, the Western Blue Ridge here in North Carolina consists mainly of Mesoproterozoic to early Paleozoic metamorphic rocks in a series of northwest directed ductile thrust sheets that have undergone polyphase deformation and metamorphism. And overprinting those are brittle structures, both fractures and faults that, really give us a lot to think about and work about, whether we're talking about rock slope stability or debris flows. And so this map here shows the geologic map of North Carolina from the 1985 maps. So the western part of the state is the Blue Ridge, where all the landslides are concentrated, but we do have a few out here in the Piedmont and even a couple in the coastal plain. But our work is focused on the Blue Ridge Mountains here. So to put North Carolina in perspective within the U.S., landslide losses and the problem that we're facing here since 1879, we've been able to document there have been at least 84 fatalities that are a direct result of landslides and at least 22 injuries. That's injuries is probably a low number, and also the number of destroyed or condemned homes at 84. That's probably underrepresented what's actually happened over historical times. And since 1990, a very low estimate of the direct losses from landslide is on the order of 53 million. And that doesn't include some of the indirect costs to, for example, when I-40 and the Pigeon River Gorge, when these, major transportation infrastructure interstates are impacted by landslides and they're closed for months, some of those secondary costs for increased transportation can be on the order of $1 million a day. And in North Carolina, we have pretty much similar types of landslides that we see worldwide. One of the areas where we have focused are debris flows, because those are the ones that have the biggest impact on public safety and loss of life in homes and infrastructure. And we have debris flows, both those that originate on natural or unmodified slopes like this one here, the Peace Creek debris flow, but we also have debris flows that originate on modified slopes. In this case, in Haywood County, this was a retaining wall that failed and mobilized into a debris flow that traveled over 2,000 feet and did serious damage to homes down here in the downslope area. And we have large, slow-moving debris slides and weathered rock slides that we affectionately refer to as big slow movers. They're typically not life-threatening, but they do pose threats and ongoing damage and resulting costs to infrastructure. So one of the big components of the North Carolina Geological Survey's landslide hazard program is responding to landslide events. And I think if you haven't had a chance to listen to Brian Collins' seminar presentation on responding to landslide events, I highly recommend it. A lot of the elements that we have at the North Carolina level are very much in parallel with the USGS has experienced. And since 1990, the NCGS has responded to over 300 or landslide events involving over 350 landslides, and 71 of those have been emergencies. And so that is really one of the core functions of the NCGS program, and is actually how the landslide mapping program got underway. And you see in this upper right hand figure, that building on fire was actually struck by a landslide. You can see the leaning trees in the background, and that landslide pushed a propane tank into the building. And that was one of the landslide responses that we were involved heavily with in Ashe County, North Carolina. And along that line, I think one of the things that has evolved in our landslide um, response program is through time, we've found that those communications are very important, but in preparing for landslide events, and that involves becoming certified in the FEMA, the National Incident Management System, and the Incident Command System. And what that allows us to do is try to speak the same language as the first responders to in emergency management, and it also builds some of those working relationships, which are important, and the chain of communications. And that also helps us in preparing our landslide response guidelines, and those are available online if you're interested on the NCGS website. And so these are things that we've done to prepare for those future events, and in responding to landslide events. Uh, you know, when we show up in a landslide, have that information in the landslide geodatabase for that area that shows where there have been landslides there in the past, to give us some notion of past historical landslide activity or even prehistoric landslide deposits, and have the lidar and orthophotography on the field computers. And this all helps with what the EM folks refer to as situational awareness. When you're at a site, you know where the landslides may have started, where they may end up, and the overall terrain. And so in responding to the landslide events, what comes out of that is documenting the events, producing GIS data layers and reports. And all this is fed back into the landslide geodatabase, which is sort of a central repository of this feedback loop. But one of the more recent additions, beginning in 2013, was the establishment with the cooperation with the US Geological Survey and the Colorado School of Mines, and landslide monitoring network. So that's proven very helpful in not only in anticipating when the rainfall and moisture conditions are ripe for landslide activity, but helping analyze what's happened after the event, and to get a notion of looking forward to when we might anticipate similar events. And so we've developed this, uh, what you might call this feedback loop of being prepared, responding, documenting, and monitoring, and helping us, become better prepared for future events. The other aspect of the NCGS mapping landslide hazard program is actually landslide hazard mapping. So in this images you see here, those labeled counties are where landslide mapping has been completed or in progress in Transylvania County. And and so one of the findings from these years of landslide mapping is one thing that's critically important is making this information where landslides have happened or might happen in the future, is making that available, readily available to the public in a format that's accessible, understandable, and connected with the landslide history. So we've worked with the National Environmental Modeling and Analysis Center, as well as our partners, Appalachian Landslide Consultants, to put together this web map viewer. And if you were to zoom in, like a lot of state surveys and the USGS has developed, you can see actually the more the detailed aspects of the landslide mapping. The red dots here were initiation zones, which in this case are debris flows. Some of the 240 debris flows and debris slides that were triggered by a May 18th storm in Polk County, North Carolina. And the yellow areas here are the outlines of the debris flow tracks. But the other thing that we see on this map are these orange colored areas, and those are deposits from past landslide activity. And what we found in North Carolina, like many other places, is where landslides have happened in the past, is a good indicator of where they might happen in the future. I think the critical point is this: the landslide mapping and inventory is a critical component of establishing where they've happened in the past, and that's an important tool and information and data that goes into modeling, forecasting where they might happen in the future. In this case, this is the probability of sliding and where they might go if they do start and debris flow runout. So these are all approaches that we might take, and there are various models out there. That I guess the case I would make is the fundamental data is important, regardless of what modeling approach you take, is to analyze, the model's performance and calibrate those models. And also, I think an important adjunct to the technical information is a companion web page that helps users explore the data, take a tour of the data guide, and in several cases put together story maps. It helps go through some of the historical events in Western North Carolina to tie those events to people's memory and things that happened before people have recently moved to the area may have experienced. So to start with, in this history of sorts of the NCGS landslide mapping program, it's evolved through time. And this graph shows some annual precipitation in Western North Carolina. As you can see, it's a pretty erratic profile where we go from periods of well above precipitation, below normal precipitation, and droughts. And these above normal periods correspond here, like in many cases, with landslide events. So to begin with, in building the landslide mapping program, the early years, these grants are important, as many people have found out, and the beginnings of establishing landslide mapping. Certainly, the FEMA grants, which started out in the early years, is hazard mitigation grants or pre-disaster hazard mitigation grants, are now building resilient communities. Those are really important sources of funding, and I know the Kentucky program and the Virginia program have done amazing things with grant money from these grant sources here. So that was really the initial beginnings of our landslide mapping program. What really started it in full force was in 2004. There were two tropical cyclones that came through Western North Carolina. I'll talk a little bit about those, but the North Carolina General Assembly, or the legislature, funded the Hurricane Recovery Act, and it funded the landslide hazard mapping program. And those funds were available from 2005 to 2011. Um, in 2011, the North Carolina General Assembly basically eliminated the North Carolina's landslide hazard mapping program. And I'll talk a little bit about that. And so several things, the confluence or collision, if you will. Several things happened during this period. And as you might recall, from 2007 to 2009 was the Great Recession. So there was a big economic downturn throughout the US. And as a consequence, tax revenues dropped. And the other thing that happened in 2007, some of the members of the Western delegation proposed steep slope ordinances that were linked to the North Carolina Geological Survey's landslide hazard mapping program, which, to point out, the NCGS is not a regulatory agency, so we do not promote regulations or, discourage them. But our role was that if there were going to be regulations that were developed and they would involve a scientific product like landslide hazard mapping, we would certainly be available to help explain what the mapping could be used for and what it shouldn't be used for. And in this case, it's a screening tool. It just points out those areas where a more detailed look before site development is warranted. But as a consequence, that mapping became politicized, and that landslide hazard mapping ended at that point. That program was cut. But during that time, we were able to, through a NASA grant and cooperation with the USGS and the Colorado School of Mines, begin a landslide monitoring program. And then again in 2018, we had a well above normal year of precipitation and more landslides. And then the sort of the happy part of this story at this point is the North Carolina General Assembly reinstated funding for the landslide mapping program. And then in 2018, that's gone forward, and those positions have since been permanent. So the basic underlining story that you all may face in landslide hazard mapping, there may be ups and downs, and during those down periods, the partnerships are really important, but also those are opportunities for other ways to advance the program, and I'll touch on some of those. But to put North Carolina in perspective, this is a very busy graph, but this is time here. This is rainfall.
Perfect. Cool.
All right. All right. We'll try again here. Thanks for the heads up. All right. Anyway, this is the time rainfall chart. and time in this axis on the bottom and the top. And this is the number of landslides, orders of magnitude, and different events been able to document going back to 1876 that have triggered landslides. So in summary, there have been 7 events since that time that have triggered hundreds of landslides, 2 events in 1960 and 1940 that triggered thousands of landslides. And if you lump those together, there have been 9 events, what I call major landslide events since 1876. And of course, one of the big problems for us here in the Southern Appalachians are the back-to-back storms, where they, particularly tropical cyclones that occur within, 2 weeks of each other. And that's happened in 1916, 1940, 2004, 2018. But although I'm speaking of North Carolina, 7 of these events have had multi-state impacts, particularly the tropical cyclones. So those are, even though I'm concentrating in North Carolina, these tropical cyclones, which trigger landslides and flooding over many parts of the eastern seaboard and the Gulf states, are a big problem as well. So stepping back into history in 1916, what are some of the things that we learned in some of our studies? This is a mapping that we did in Gorges State Park in Transylvania County. And in 1916, in August 13th, after 20 inches of rainfall in 24 hours, the Lake Toxaway Dam failed catastrophically here. And this was an earthen dam, and this was a recreational lake. This was a 200-room inn at the time. This is where the Fords and the Firestones and the Edisons vacationed over the summer. Well, that dam broke, and the outflow we estimated was on the order of 50 miles an hour, or the velocity, and the outflow is on the order of nearly 300,000 cubic feet per second. But that triggered a massive debris flow all the way down the Toxaway River through North Carolina into South Carolina. And we were able to map these deposits out and document these anthropogenic debris flow flood deposits in the geologic record. And that was a seminal event for 1916, but I think one of the fundamental things here is that damage extended over 22 miles down the Toxaway River and over 16 miles or 26 kilometers into South Carolina. So, and the Georgia State geologists, not to put too fine of a point on it, approximately 5,376,548,571 gallons of water changed hands. And all the newspaper accounts, and in North Carolina anyway, said that the dam and the power plant represented the main property loss. As you can see here, that property loss extended well into South Carolina. So I think 2 very obvious points here. One is that your state or the federal dam safety programs are incredibly important, but also it's have a firm grasp on the obvious. The laws of physics don't stop at property boundaries or even state lines. And this is one of the issues that's central to landslide hazard mapping when you're dealing with private property, is that private property is permitted, managed, bought, sold at the parcel level, but many times landslides have little regard for property boundaries. So that's one of the challenges we face in landslide hazard mapping and conveying the potential hazards. While we're on 1916, as it turns out, that year was also the year of the record rainfall for Western North Carolina, and that storm dropped over 22 inches in 24 hours along the Blue Ridge Escarpment, which is the mountain front here in Western North Carolina. And this work is building on some of the work that Ann Witt started when she was with the NCGS, documenting these areas that had landslides and landslide fatalities in 1916, all up and down the Blue Ridge Escarpment. You can see these red areas right here. And we've actually been able to pin down some specific locations of these. These are some of the debris flow tracks in Hickory Nut Gorge. This is where the progressive failure of brittle rocks field trip is going to be. So we'll be concentrating on rock slope failures, but we'll also be looking at some of these debris flow events. And this was, flood destruction in over 5 states. So this was a big event in Western North Carolina, but we'll come back to that. So what really began the landslide hazard mapping program in Western North Carolina was the tropical cyclones Francis and Ivan in 2004. And this is the map of that Western North Carolina, the landslide inventory. So all the blue dots that you see here are some of the 250 landslides, mainly debris flows and debris slides that we know were triggered by that storm. And what you see on this page are some more of those examples of modified slopes that failed in the form of debris flows. This was an embankment failure that destroyed a house. And these are some of the embankments on the Blue Ridge Parkway that failed and traveled all the way through the Pisgah National Forest. Again, illustrating that, you know, we're all neighbors on the hillsides here, whether the property boundaries divide us or not. And this is to give you an idea of some of the size of the debris flow deposits in the downstream area. These are some of the boulder and large woody debris deposits you see from these debris flows. So they're very destructive here, as in many places worldwide. And the seminal event in the 2004 storm was the Peaks Creek debris flow. And that is one that started on Fishhawk Mountain and traveled 2.25 miles down Peaks Creek to the Calisaja River. And in that course, there were 5 fatalities, including an unborn child and 16 homes destroyed. And the NC General Assembly provided $3.2 million for a voluntary buyout, because one of the tough lessons that the property owners learned here is that their homeowners insurance does not cover landslide damage. And this was a big landslide response effort on part of the NCGS, where we're advising the local emergency managers on the stability during rescue and recovery operations, and participating in an interdisciplinary task force to document the debris flow, and then the investigation and mapping, which ultimately led to the landslide hazard mapping in Macon County. But one thing that responding to landslide events has been, I think, an important component of the program in North Carolina, but it comes with a price. In some cases, you can get involved in litigation and expert witness testimony. So that's one thing to be mindful of if you are working with landslides, whether you're responding or not. There's always that potential. And of course, sticking to the facts is an important component of those situations. One of the things that we learned when storms and mountains collide, and this is probably true in North Carolina as many places worldwide, that we see higher amounts of rainfall at higher elevations, that orographic forcing of rainfall. So we see that both in Francis and Ivan here in these rainfall maps. And in this plot here, you can see the higher rainfall amounts are in the rain gauges with the higher elevations. This is data from the USDA Forest Service Coweta Hydrologic Research Station in Macon County, North Carolina. So again, an important partnership with the Forest Service and the National Weather Service in documenting the meteorological effects and situation scenarios with Francis and Ivan in 2004. And also that became very informative in seeing the pattern here in Western North Carolina that's seen in many other places, that the triggering of debris flows is often tied very much to the rainfall intensity or rate and duration. And as you can see here, in those situations where we do have good rainfall data and the timing of the debris flows, you can see in this cumulative rainfall graph from the Coweta Hydrologic Research Facility that both the Peaks Creek and Wye debris flows occurred in this steep period of rainfall here, where it rained on the order of 25 millimeters an hour for about a little over 4.5 hours. So that's an important finding that we will come back to later in what this means with respect to modified versus unmodified slopes. But in this particular situation, you know, Hurricane Fran had come through about a week earlier. This is a spiral rain band within Hurricane Ivan, and this is when this passed over Macon County. That's when these two debris flows occurred. Moving forward in history, another important event in Western North Carolina was, again, a tropical cyclone that came in off the Atlantic and tracked over Georgia, and then made a right hook and came over the western part of North Carolina, Watauga County. And mapping that county, we identified over 2,000 landslides, mainly debris flows that were triggered by that storm. And there were 14 landslide fatalities, over 32 structures destroyed, and US 421 was severed in 21 places. And we were able to map these because we had the good fortune of having 1940 vintage aerial photography that we could scan and georegister and bring into GIS and use with lidar, get a pretty good idea of where these tracks are and initiation zones. And so these yellow dots, these points on the map, are those 2,000 plus debris flows and debris slides that were triggered by that tropical cyclone in 1940. And here's a close-in view of the deep gap reentrant in the Blue Ridge Escarpment where there was a high concentration of debris flows on the order of about 600. So what we see here, again, these pink areas are the tracks of the debris flows, and they deposit material pretty much in the same locations that are shown by these prehistoric debris flow deposits here. Again, a very similar pattern we see here in Western North Carolina in most places where we map debris flows. So what are some of the lessons we learned from Montauk County? Looking at 2005 orthophotography, since 1940, over 130 structures, mainly homes, have been built in the tracks of these 1940 debris flows. So here's a 1940 view, and here's the same view, 2005, and here's the home right here. And we're often, concerned about what the recurrence is for debris flows in particular locations. 15 of those debris flows that occurred in 1940 reactivated in 2004. That's a very low percentage, but I think the interesting fact is where those debris flow tracks reactivated in many situations is where those slopes had been modified, in this case by a fill slope. So what might create a shorter turnaround time between debris flow events can oftentimes be related to modifications to that site by human activity afterwards. And what we also learned from that event is that, at least in some of these locations along the Blue Ridge Escarpment, like the deep gap reentrant here, at the watershed scale, the debris flow frequency is probably on the decadal scale. In this area, there were debris flows and debris slides in 1916, 1940, 2004, and 2000, and again in 2018. So part of preserving that information is in making that record available, those storm events, the impacts, the stories of people, and in that effort, we tried to do that in the Carolina Geological Society field trip in 2018, and in Boone now. This is that 1940 event is documented by a historical marker that ties back to our work that storm triggered over 2,000 landslides. So I think that's important in trying to preserve the memory and the recollection of what happened in these events. So that's some of the mapping that happened while we had funding. And this is, again, this is coming back to when the program was temporarily ended in 2011. But in 2007, that's when this legislation was introduced that required realtors to disclose landslide hazards, required a geotechnical report for construction on slopes greater than 40%, which is about 22 degrees. And from our data, that was a good indicator of the ground slope when you would expect to see an increased number of landslides under certain conditions. It was right around that 22 degrees or 40% mark. So that slope was based on the landslide data we had collected, and also that was linked to areas on the landslide hazard map that show a moderate or high hazard for debris flow susceptibility. And so that legislation met considerable opposition is because there were concerns over private property rights, property values where landslides have been identified, and the added expense of geotechnical reports, and just the overall sense of it was more regulations. And in some quarters, it was felt that that was government overreach. So these are some of the things that you might encounter, and some of the opinions that were expressed about the landslide mapping. Just be prepared for some of the things you might be exposed to if your mapping comes to the forefront, or it's some people take objection to it that landslide maps are just junk and they should be tossed out. Steep slope regulations in the U.S. have been eroding private property rights for over 50 years, and we're getting back to that issue of landslides don't necessarily respect property boundaries or property rights. And of course, we all know that landslides have been eroding private property a lot longer than regulations. But the argument that won the day in the North Carolina legislature was the landslide mapping is just a backdoor approach to more regulations, and I ask that you vote against it. So that was the ending of those positions and funding. But that provided an opportunity. It was a challenge. From 2011, 2018, the landslide mapping stopped. The landslide did not, however. So we were still responding to landslide events, but that was a great opportunity to establish that landslide monitoring network with the cooperation of the USGS, the Forest Service, School of Mines, through a NASA grant. But, you know, with every opportunity comes a challenge. You know, if you've been involved in landslide monitoring, you know that involves a lot of maintenance. And we gave up at this one site here. We decommissioned the Dobson Mountain site when the score was Bears 2, rain gauges 0. So that's one of the things you can encounter with landslide monitoring is the wildlife. But some other lessons were learned during this period. This is the Piney Mountain landslide that activated in 2013 after a bank foreclosed on this parcel, you know, after the great economic downturn. And this landslide began to move. And as it turned out, the bank was willing to do whatever it needed to do to stabilize this. They took full responsibility for stabilizing this, and to the cost of nearly $5 million. As it turns out, the foreclosure of this parcel was beneficial to the Stonebridge community. And but through this process, and the bank certainly gained a heightened level of awareness on lending practices in landslide-prone areas. So a lot of times, society has to learn problems the hard way. But this is information that was courtesy of Appalachian landslide consultants. The other thing we learned in 2016, you know, that was the 100-year anniversary of the 1916 event. That this is a film that was produced by David Weintraub, and it was nearly an hour and a half long. And I had the good fortune to sit in one of the premiere viewings of this. And for an hour and a half, everyone in that auditorium, there were probably over 200 people, were full attention, rapt attention was paid to this film and the stories of people whose ancestors survived and those who didn't. And so I think, I don't think anybody could stand listening to my scientific talk for an hour and a half, but this is one of those opportunities where the historical context told through personal accounts and videos had a big impact on people and helped get that message across on the importance of landslide history in a region and why we should be mindful of those things going forward in the future. 2018 saw a record year for rainfall and landslides. This is a debris flow that was a fatal debris flow in Polk County, where two debris flows converged, where this house was sited right here. And what we see here in this situation again is in this debris fan where this house was situated. There are pre-existing landslide deposits, and this gives you an idea of some of the imbricated, the size of the imbricated clasts in this pre-existing landslide deposits here. So these, again, these debris flows are very destructive and travel in excess of 20 miles an hour. And so that May 18th event triggered over 240 landslides. There was one fatality and several homes destroyed. So that reinstated the interest in landslide mapping. But in that same year, subtropical cyclone Alberto came through at the end of the month and struck the town of Chimney Rock in Rutherford County. Here's some of the debris flows, and this is some of the debris slides that impacted the volunteer fire department there. And again, here's where the monitoring system shows these rainfall intensity and duration of the May 18th storm, as well as the Alberto storm, which came later that month, but also subsequent storms, Tropical Cyclone Florence, and another localized storm on September 30. And so why is this relevant to 1916? Well, let's step back again in history. This is a photograph taken from Chimney Rock State Park, looking back over to Round Mountain here. And these are tracks and deposits from debris flows in 1916. And here's a debris flow deposit that came down this valley right here. And we're looking at this location here. And let's zoom in to locations A and B in 2020. This is a LiDAR comparison map from the pre-storm 2017 LiDAR with 2020 LiDAR for change detection. So these are the tracks of the 2018 debris flows that initiated on this embankment here that travel down the same paths as the 1916 debris flows here at location A and B right here. So again, when we come back to where, you know, what may be a longer recurrence interval on natural slopes, these can be short-circuited, if you will, with unwise or development on these mountain slopes. So these things that may take 100 years or so between times, or point out the importance of documenting these landslide events that have happened over time in these areas, because these can be places where landslides can reoccur under natural circumstances or even on shorter time frames with modifications. One of these examples of a slow-moving landslide, these situations take time to evolve, where this road was widened in 1969, and over these successive years, there was damage to homes. 2 were condemned in 2019. And in 2019, there was litigation over disclosure by the person that bought this house. And during that time frame, both the realtor and the seller gained what you might call a heightened level of awareness. And so the positive outcome of this was that realty company has added landslide map review and disclosure into their best practices policy. So everyone's beginning to learn the importance of this work and why it's important to know where these hazards exist. And very briefly, another seminal event in 2019 were post-wildfire debris flows in Western North Carolina. We were under the false impression that was mainly a problem in Western US, but in the Nantahala Gorge, and this intense storm, it triggered over 16 debris flows. 4 of those were major, where some of these 16 merged into 4, and the Nantahala River was blocked. There was a lot of damage. And so our role was to provide information to the stakeholders in the form of maps and GIS data layers. All these stakeholders, local emergency managers, Forest Service, Duke Energy. So there are many stakeholders in this. Again, what we see here is that at least a physical connection, spatial connection in this burn severity map created by Steve Norman with the U.S. Forest Service, all the major debris flows started in or near the most intensely burned areas. And this is a map that was derived from the Normalized Difference Vegetative Index from the Sentinel-2 satellite imagery. So that's another important tool going forward. So 2018, 2019, banner years for landslide activity. The NCGS has its own drone now, and so that's an important tool in responding to these landslide events. And what you're seeing in this video here is a video of the track of the Dobson Mountain debris flow here in Western North Carolina. So the scour line, to give you an idea of the destructive power of these debris flows, the scour line is probably on the order of 70 meters above the stream channel bottom in these locations. So fortunately, this house was not located in the path, but this is one of the many landslides that the NCGS responded to, but where the U.S. technology was incredibly important in providing that information. The other thing that I think is important in a landslide mapping program, or just for geologists, professionals in general, in Western North Carolina, the National Forest, they're the largest landowner in Western North Carolina, and they have their share of steep terrain and consequently their share of landslides. And some of those that start on National Forest land end up on private property. And so our information is readily available to the Forest Service. They've used it, and thanks to Tom Collins, have incorporated that information in the National Forest planning process for the Pisgah and Nantahala National Forest. So if you're a geology professional, and whether you're a state agency, a federal agency, or private entity, it's certainly the National Forest planning process. It's an important place to have your voice heard on landslide hazards. So I encourage you to take advantage of that if that opportunity presents itself. So what can we learn from these past landslide responses? Well, if you look at the number of landslides in the database, they're shown in blue. The number of responses to the total number of landslides is pretty low. But if you look at the distribution of responses to landslides, responding to landslides on unmodified slopes makes up, although very important because these are where the fatalities occurred, many of our responses involve landslides on modified slopes, whether they're cut slopes or embankments. And so I think the good news here is, with the right information on geologic input on siting and geotechnical input on design and construction, many of these can be avoided. The other thing that we see in terms of rainfall and intensity and duration, at least the broad pattern where we've been able to document rainfall intensity and duration in landslide events in this area down here, are those landslides on modified slopes. So you see they occupy lower intensity and durations than most, if not all, of these landslides that have occurred on natural slopes. So again, I think the point is, with developing on steep slopes, we have the opportunity to make that situation better with the right geologic and geotechnical input. So to start wrapping things up here in Western North Carolina, we have a year-round landslide potential, both from high intensity localized storms. They're localized, but they occur with little warning, low pressure systems, including atmospheric rivers, certainly tropical cyclones. And then when these storms occur within extended periods of rainfall, like you can see here, but what we think are I think are the climate change signals, we have this alternating extreme weather patterns from well above normal to below normal, and including droughts and wildfires in those below normal periods, and an increase in these high intensity convective storms, where the rainfall intensity and duration is exceeding that threshold for triggering debris flows. We've been seeing an increase in those number of storms over, certainly going back to 2009. So again, that's a pattern I think is located to or related to climate change. So this is where I end up with in all my landslide talks. Pretty much, it's all connected, and we're all stakeholders in helping reduce losses from landslides and building resilient communities. Both there are many disciplines in geoscience that can be brought to bear, and in geotechnical engineering, but these are the folks that we need to reach out to and bring to the table. And I think building those relationships with emergency managers. I know Brian Collins emphasized that in his talk. This is, I think, incredibly important to build these one-on-one working relationships with these folks, so they understand the landslide mapping and understand how it should and shouldn't be used. And in that regard, I think at this point, we all have a compelling opportunity within the geoscience community to press forward in a coordinated effort. We have a lot of new technology, lidar, drone, satellite imagery, machine learning. The National Landslide Preparedness Act is passed, and hopefully there'll be funding in the pipeline before long. And we're all seeing the ongoing impacts of extreme weather patterns linked to climate change. And to meet this challenge is building those partnerships, I think, again, to emphasize this point, both within and outside the scientific community, and to engage stakeholders to increase that level of awareness. And these are some images of a fatal debris flow and flooding from Tropical Cyclone Fred in Haywood County, North Carolina. So again, I will wrap it up. Thank you so much for your attention, but I want to say a big thanks to all of the partners that you can see with their logos here that have helped with this effort and to make this effort possible, and hopefully continue it going forward in the future. So thank you very much. I appreciate your attention. I'll be happy to try to get any